Hello and welcome to LogiCast episode 3. I'm Karl Robinson and I'm with my colleague John. Those of you watching by video may not recognise him, but I can assure you it is the same guy that's been on episodes 1 and 2. So what happened, John?
I had a fight with a lawnmower.
Oh dear. I hope the lawnmower came off okay.
Yeah, I sharpened it afterwards. No, my beard trimmer didn't like me, so now my face is cold.
Well, it's like having another new colleague. So if we can treat you as a separate employee, perhaps we could double your workload. I think that answers that question, doesn't it? Yeah. So let's move swiftly on. So welcome to LogiCast episode 3. If you haven't listened to the podcast before, every week we take a look back at AWS news for the previous week. And we pick out a number of articles that we think are interesting and worthy of discussion. If you haven't seen our weekly AWS news roundup, we send out an email newsletter once a week with a curated set of AWS news articles. And then in the podcast, we take a little bit of a deeper dive and just talk, give you some opinion and a little bit more of an in-depth discussion around those articles. So this week, the first article we have picked on is an article on data center dynamics about a new tool available from the Uptime Institute, which shows you the emissions savings of migrating workloads between different AWS regions. So often when you are looking to site your workloads, there's going to be a number of factors involved in choosing where to put them. The most normal one is proximity to either you or your customer base from a latency perspective. Then there are things like data sovereignty. Does the data that you are storing need to be stored in a specific location? But obviously sustainability is becoming higher and higher on people's agenda now. So this tool definitely caught my eye in that sustainability vein. John, tell us a bit more about your understanding of this tool and what it actually does.
So the article is a little bit frustrating because it doesn't have a link to the tool. But what the tool does is it has options for Amazon Web Services, Microsoft Azure, I don't know how you pronounce that one, and Google Cloud. And it shows you in a nice graphic the various regions that they support, right? Whatever that cloud provider refers to as a region, because that varies depending on the provider. You sort of click through this nice interactive graphic and it shows you the sort of grid emissions for that area in equivalent metric tons of CO2 per kilowatt hour. And it shows you the cost of a standard instance. So they've picked the same instance across the board, which is an M5 large. Presumably they've picked that so that the numbers are big enough for it to make sense. Because if you're charging it on a T3A micro, then it's fractions of a dollar, fractions of a cent, you know. So they've picked a fairly sort of meaty instance, so you've got some numbers that make sense. Yeah. And you click through that, and it shows you, depending on sort of the region that you're in, regions that you could move to or from into that region or out of that region have similar experience in terms of latency for your user, and whether the cost goes up or down, and whether the emissions goes up or down. Right? The reason, of course, for this being that data centers, the reason rather for the numbers being different in different regions, is that it costs different amounts of money to produce the electricity needed to run the data centers in those different regions. So that's where the grid CO2 emissions comes from, because the amount of money it costs, the amount of CO2 it costs, depending on where you're producing it, changes those numbers. And we touched on this last week in the data center under the sea piece that we sort of did, because up in the Orkneys, power is cheap because there's lots of surplus power because of all the wind farms and things. So that's kind of the idea behind this. It does, like I say, it does it for AWS and for Azure and for Google Cloud, which is quite cool.
Cool. But don't the cloud providers, in particular AWS, have their own tools for doing this kind of thing?
Not to the same extent. So you could argue that they do, because they will tell you that the prices for different regions are different, but they don't tell you what that's based on. So if you look at users in the UK will be very familiar with AWS in particular, because Ireland, EU West 1, and London, EU West 2, London is more expensive. And the latency, if you're in the Midlands between them, is about the same, really. I always put that down to London real estate, that's the word, being more expensive. So they have to pay more rent for the same amount of server space, so they have to charge you a bit more money for it. What Amazon does do, I'm not familiar with Azure and GCP so much, but what AWS does do is in your cost and usage reports, they give you a carbon emissions report. So looking at Logicata for Jan 2020 to July 2022, I can see, and it's configurable down to the month, I can see the equivalent metric tons of CO2 we've emitted, which is not a big number at all, which is great. But yeah, so they kind of do, but not to the same extent, not between regions, just sort of what you have done.
Cool, got it. We are very environmentally conscious at Logicata. In fact, this week we even considered adopting a beehive in Sussex. I think I was feeling a little bit guilty after having killed about 10 bees that came into my house to die, so I ought to do something. They were on their last legs, so I felt that I was being cruel to be kind. But yeah, perhaps I'm feeling a little bit guilty, and I can right that wrong by sponsoring the beehive. But there we go. Slight digression from me, as always. But thanks for that overview of the emissions saving tool. The next article we picked on this week is about VDI. AWS targeting desktop virtualization rigs with lift and shift to cloudy DaaS. DaaS. What's DaaS, John?
Desktop as a service. Not to be confused with the washing powder, DaaS, with a Z.
Because I think people generally do pronounce it DaaS, but yeah, definitely don't get the two mixed up. So I had a little bit of a read about this article, and I can see this is really more from the partnership between VMware and AWS. So VMware Horizon and Citrix, of course, are the two leading forces in the virtual desktop infrastructure market. And what it seems that AWS have done here is put the VMware Horizon virtual desktop infrastructure management layer in front of their own workspaces proposition, with a view to taking some of the market share of the hyper-converged infrastructure providers, because right now, if you're running VDI, chances are you're running it on hyper-converged infrastructure in your own data center. But hyper-converged infrastructure is very expensive, and anyone that's coming to a hardware refresh cycle on their hyper-converged infrastructure probably is going to be looking at cloud-based alternatives, particularly if they're looking to wind down their own data center operations. But yeah, tell us more about DaaS, John, because I know you've got some history in the DaaS space. I know you've probably washed your Logicata t-shirts with it, but that's not what I'm asking about. I'm asking you to talk about the desktop as a service side of DaaS.
Yeah, so in the past I worked in a regulated industry. I worked in a finance company, and we used desktop as a service. For security reasons, privacy reasons, all that sort of thing. Right. The staff liked it because you had the same desktop at home when you worked at home occasionally and in the office. And you didn't have to lug laptops and things to and from the office on a regular basis as well. So that was great because you didn't have to worry about it. The way that worked was when you were in the office or when you were at home, you authenticated to a portal. It was Citrix, I think, that we used, and then you got your desktops from there. Right, and depending on the sort of the team and the department, your desktop was anything from just really locked down word processing, Office, Outlook, that sort of thing, right the way up to full admin rights, and in some cases even Ubuntu instances if you had need for that. The way that worked in the office was that there was either a sort of a cheap PC under your desk or a thin client, as they're called sometimes, which is just a skinny Linux box mostly, and it would just connect off, you'd authenticate, and you were away. When you're at home, because you didn't have a thin client and the thin clients wouldn't work outside of the LAN, you ended up on your own personal laptop or your desktop or whatever, and most people were okay with that. It bothered me a bit because the only PC I owned at the time was a gaming rig that sat there consuming 800 watts of power. It really didn't, but it could have done, and chucking out a load of heat, so that was a little bit annoying. But that was the sort of the short version. With this, as you quite rightly say, what they're doing is they're targeting users of that existing service and just saying, well, instead of running your own infrastructure, give the infrastructure to us, which is what they've already done with things like website hosting and that sort of thing. It's the same business model, just for a slightly different market segment.
Cool. And I think you mentioned a specific customer to me earlier that where you had some experience of them rolling out VDI. Do you want to touch on that again?
Yeah, okay, sure. So it wasn't a customer as such. It was a local firm to us in the Sussex coast, Sussex by the sea, of Crunch Accounting. You might know them by. They're an accountancy platform firm. Yeah. When the reason that everyone stayed at home for 2 years kicked off, that was their give everyone access to the systems remotely setup. I think they used AWS client VPNs to connect to AWS workspaces, and then the workspaces were just in the network because most of their stuff was cloud-based anyway, so they could do that, and that was fine. And anything that wasn't had a VPN connection back to the office. Happy days. That worked for them. That worked quite well, but it's quite expensive, to the extent that after the sort of initial shock and panic of everyone go home and stay there had sort of subsided, 6 weeks, 8 weeks, something like that, they started ordering people sort of cheaper laptops and shipping them out to everybody. But of course, when this was all kicking off, you couldn't do that because everyone else was doing that. So they went down this route because it was something that they could roll out quickly, not cheaply, but effectively and efficiently, with having like 3 members of staff do it. I think it was the Register that had a fairly deep dive into that whole setup with the IT guy and his boss on that. So that's well worth digging out. If I can find it, I'll put it in some sort of comment if I can find it.
Cool, thanks for that. So let's move on to the next article, which is another one on the Register. The Register are doing well out of us this week, getting lots of exposure on the LogiCast podcast. But this one is about the Snowball edge compute appliances. I love these things, and I wish I could have one in my office. I'm not quite sure what the use case would be, but I just think they're pretty cool devices, to be honest. Of course, Snowball started off as a way to get your data into the cloud. A whole bunch of hard disks in a ruggedized box that you could plug into your local storage infrastructure, dump all your data on there, and then ship it back to the Amazon cloud, where they plug it in and upload all of your data, just to save the time it takes to upload the data over the wire. But of course, it's evolved now into these edge compute optimized appliances that can actually be used out in the field to do actual data processing. So tell me more about these, John. It sounds like they're getting super powerful now.
They're basically servers these days. So yes, you're right. The original Snowball, for those of us who have done the A Cloud Guru training course, are familiar with it. The original Snowball was a ruggedized box with a bunch of spinning hard drives in there and a little bit of compute power so that it could kind of move the data around, and an e-ink shipping note powered by a Kindle, which I always thought was quite cool, that they used Kindles for the shipping note so they could use the same Snowballs repeatedly and not have stickers all over them. So that's quite cool. They eventually did Snowmobile, which is the big truck thing, but the purpose of this article is Snowball Edge. So what they've done with Edge is they've just made the compute element of that storage significantly more powerful, and they've just kind of done that again and again and again. At this point, the Snowball Edge at the top end has an AMD EPYC CPU in it with the Rome architecture, which is really beefy. It's 32 cores, 64 threads at 3.4 gig. That's mad for a server CPU. And then on top of that, it has memory capacity to 0.5 terabyte of RAM and 28 terabytes of SSD NVMe backed storage. That's insane. That's basically a server, and not even a mini one. It is a full fat-fledged server in a tiny little package, which you just plug into your data center and away you go. The server itself connects to your network through a number of options depending on your setup and how much of a nerd you are, because it's got 10 gig Ethernet over RJ45, and then it'll do 25 gig or 100 gig over SFP and QSFP, which is those big chunky meaty connectors if you're not familiar, which is insane.
I was actually going to jump in there, but I bit my tongue when you made the comment about how much of a nerd you are, because I know you are quite a big nerd, John. So you love to have a nerd off about these things. But, we work in IT, so that's what it's all about. So what are some of the use cases for these things? What are we going to do with all that compute power in this lovely little device with an e-ink label on it? What do people do with these things?
Spend money. So, no, being serious. What they do, the upshot, so Amazon have started doing this in more than just this particular product. What they're doing is they're putting things in your data center that you can access through AWS's services. So you can treat things in your data center as if they're not in your data center. So you can access things on them, via the AWS console. Now, why would you want to do that? Well, you want to do that because you've got a whacking great data set, like we spoke about the other week with Storage Gateway, or whatever it was at the time, file cache. You've got this whacking great data set that you want to put on the box, and you need to do some processing on said box. It's the same sort of concept. It's just this is a bit more self-contained than something like file cache, because file cache was just hook some drives up to it and off it goes. This is a piece of hardware that you can put in your data center. So that's kind of the idea, is it lets you do processing using the cloud with your data not on the cloud.
I think some of the use cases I've seen are people who don't have data centers. So because it is a ruggedized box, it could be used in the field. So it could be used by the military, it could be used by oil exploration, for example. If they're just setting up temporary sites, they need to get a whole bunch of compute in and analyze large data sets. Oil exploration is a great one, actually, if they're drilling data, etc. I think these are great field-based devices as well. But I'm a bit of a nerd as well, John, and I too thought that the e-ink label was the best feature for me. The fact that you can just scrub it off, stick a UPS label on there, other carriers are available, and get them to come and pick the thing up and ship it back to the cloud. So let's leave the Snowball edge behind for the time being, and move on to the next article we picked on, which was this about the IAM role trust update. I don't know anything about the IAM role trust update. This article's entitled IAM role trust update, what you need to know. So I suppose what I should do is read it. But what I'm going to do is ask you, John, because I think you do know a little bit about it. So enlighten me. Give me the TLDR version.
The TLDR version is I've read it. Okay. I jest.
Give me the slightly longer version.
So, if anything, I think it was a bug that's been addressed. That's kind of the way I sort of interpreted this. Up until the recent announcement, which was September 21st, IAM roles could implicitly assume themselves. Now, what does that mean? What that means is the role could reassume itself and then do things with that. Why would you want it? So, with most of IAM, roles assume other roles, they go off and do things, right? EC2s have instance profiles which they assume, and then from there, that role can assume other roles so that it can do things. It has permissions, but only whilst it's assuming that role, not permanently. IAM roles could assume themselves, even if it wasn't explicitly stated that it could do that. That is a problem. Why is it a problem? The article sort of points this out. It's inconsistent. It's the only thing that could do anything implicitly in AWS was an IAM role assuming itself. So they have removed that, or they are removing it soon. I think they have already done it. So it's consistent with the rest of the IAM setup, basically. That's sort of the big part of it. On top of that, it means there isn't this hidden enumeration risk that people don't really know about, because I personally didn't even know it could do that until I read the article saying it wasn't doing it anymore, because it's really not something I think you should be doing. And to be fair, according to the announcement, only approximately 0.0001% of all IAM roles use it. So it's not a big amount. I mean, it probably is a big amount in numbers, but it's a very small percentage. It might be used in something like your deployments where it reassumes itself to change its own permissions or something like that, or it changes its permissions and then it assumes itself again so that it can then use those new permissions. But it's not something that's that's common. And if you don't know whether you need to do anything about this or not, AWS will tell you whether you need to do anything about this, because they're quite good at that. But if you see any announcements from AWS in your inboxes, don't just delete them. But that's what it's doing. If this is something that you need to do, the obvious thing to do is go into the roles that are affected and explicitly grant them permission to assume themselves in the trust relationship. If you don't know that you need to do this, but Amazon has told you need to do this, set up a CloudTrail event for lookup events. And if you know you need to do this, and you know why you need to do this, and you have the time to refactor, I'd recommend refactoring away from the behavior. But that's the short version.
Cool. I don't think we need to hear the long version. I think the short version will suffice for now. So before we skip on to the final article that we wanted to pick on today, I just wanted to bring up the subject of our lunch yesterday, and how our dessert choices seem to very closely match our podcast roles, as the waitress pointed out. I'm not sure she's a listener of the LogiCast podcast, but she certainly pointed out that our dessert choices did kind of closely match the way we were conducting ourselves in the restaurant. So if this was a live show, I would ask people to phone in and perhaps tell us what the dessert choices were. But it's not, so I'm just going to go straight into it. So for your dessert, John, you chose the waffle, and I chose the cheesecake. And as the waitress pointed out, that while you're in the restaurant, all you did was waffle, and all I did was be cheesy. So it's very much like what happens on the LogiCast podcast. So not sure if there's anything to read into that, but just thought it was a nice little anecdote to bring up before we segue into our final article this week, which of course is an article written by you, John. So if you can't talk about this one, then you're not going to be able to talk about any articles. We published a blog post this week on the Logicarta blog, logicarta.com/blog, called AWS API Gateway Pricing Explained. And it's you, John, that has explained it. So tell us a little bit more about AWS API Gateway and the pricing structure for it.
So before I do that, I'm going to quote a well-known sort of audio book, the Pub Landlord's Book of Common Sense. If you go onto the website, you can see the pretty pictures. If you listen to me, you can hear my voice, but you can't see the pretty pictures. He pays you money, he makes a choice. So, what is API Gateway and what is the pricing? API Gateway is a managed API service, obviously, that connects to a bunch of other things in AWS. It connects to EC2s, it connects to step functions, DynamoDBs, Lambdas, whatever. Lambda is a common integration, right? What that means is you don't have to be a website developer, I know I'm not, to be able to competently put an API out there that does something. Be that, looks at stock prices, the training example is a pet store, that sort of thing. Yeah. You don't have to know how to craft APIs and do all the message transfers and all that sort of thing. You just say gateway, backend integration, write the logic for the backend, bish bash bosh. It's done. It works. Great. There's 3 types for API Gateway. There's 2 of them are kind of the same thing, but like one's a slim version of the other. So there's REST APIs, HTTP APIs, which is a slimmed down REST API with limited functionality, but the upshot of it being a bit more limited is it's a bit more opinionated, so it's easier to interact with if it's kind of the service that you need. And then WebSocket APIs as well, which if you're not familiar are used with things like online games and stuff where you need regular bidirectional communication as opposed to call and response, which most APIs are. What API Gateway does, as I say, is it provides you with a web interface, which you can put behind a custom DNS or not, which you can put behind HTTPS or not, which you can put behind an authorizer, be it Firebase or some other external JWT or Amazon Cognito or Lambda custom authorizers or not. You don't have to have them authenticated if it's appropriate not to. And it'll send a request to a backend, do some processing, send it back out again. The examples that I use in the article are, like I say, is an HTTP API talking to a Lambda backend or a REST API talking directly to DynamoDB. So you don't have to put the Lambda in there to grab the data out of DynamoDB, transform it and send it out the door. API Gateway can do that directly, which is quite cool. And then I'll talk about pricing, because that is sort of the point of the article. The pricing, I'm not going to go into massive detail here, but the short version is 100 million requests a month would cost you $100. It's pence. It's nothing. It's really, really cheap. The pricing is a little bit different depending on whether it's an HTTP API, a full-fat REST API, or a WebSocket API. HTTP APIs are the cheapest of the bunch because they're the slimmest of the bunch. REST APIs are 3.5 times the cost of HTTP APIs at $350 for 100 million requests. So it's still not big money, but it is 3.5 times the money. And then WebSockets are charged slightly differently because you pay for the amount of data that moves across the wire rather than the number of requests, because that's not quite so clear cut with a WebSocket. I talk about the catches and the alternatives. There isn't really a catch. You do pay EC2 data transfer rates for things leaving the cloud, which you sort of expect these days. I think those rates are quite expensive, but most APIs aren't shoveling shed loads of data down the wire anyway, so not really a thing. And then alternatives, I talk about that a little bit as well. There's a few that you could use, but the obvious one is an ALB is an alternative for an HTTP API, because it can have a Lambda custom authorizer, and it can talk to Lambda backends, and it can talk to EC2s. So you could do that. There is a point at which ALBs become cheaper than API Gateway, but it's at something like 30 million requests a month, and they're not a lot cheaper if you turn WAF on, and you kind of get that free and gratis with API Gateway. So it's like, okay, do you need it? Maybe not. But yeah, that's the audio version of the blog. Or you could go and look at the blog and hit the play button at the top and have a nice automated lady read it to you instead of me.
I was actually going to point that out and just mention to anybody listening that they should not expect to hear your voice when they press the play button on the blog, because it doesn't sound anything like you. The bearded you or the clean-shaven you. Doesn't sound anything like either of those people. But thanks for that great overview, John. As you mentioned, you can check out that post on the blog. And in fact, you can read all of the articles that we've been talking about in our weekly AWS News Roundup newsletter. So that brings us neatly to the end of episode 3 of LogiCast. So thank you for listening. We hope you've enjoyed it. If you have, please rate us on your podcast distribution platforms. Please share the link to the podcast. We are available on all major podcast distribution platforms, and we will be back again next week with another episode deep diving into the week's AWS news. So thanks for listening. We will speak to you next time.